Good morning, everyone, and welcome to my new video about um an automated maze generation that I have created for Unity. It's a very simple toolkit, like just a few components. And let's start with the most important one that is called Maze Owner. And this is basically most of the general things that we define to create the maze. So let's start with, we add these two different objects on the scene. As you can see, they can be in any direction, and the maze will be generated relative to these objects' rotation. But also not just rotation and position, not the scale. So let's move in to see what these means. So the size is basically the size of each cell. If I go zoom into one of these floors, like for example this floor here, it's not like the best angle, so I find another one, or maybe this one. So the size is this dimension, so it's like the floors are in like a square, so the size defines by the whatever the unit this has, the width and length of this square floor, and the height is the y distance between this floor and the one above it if we have more than one level. And so we have columns and rows that are the number of the cells inside the maze, and the level count, which is 2 for this particular maze. And let's now talk about these fade ones now. And the view modes, we have three different view modes: the first person and two third person views, which one of them the camera rotates when the character rotates, and for the other one only the character rotates. And for the third person views, we have the camera distance from the person. So another important thing is this vision offset mode. So so basically we can have like massive mazes, and it is important for us to optimize the number of objects active in the camera's viewpoint, and especially if we have transparent objects, because that will be like that will be very high cost for the graphic like the graphic card. So what we do here is to calculate all the cells that theoretically are visible from each cell. And so imagine this was the maze, and this cell could have only viewed like this bunch of cells around it, so there was no reason for the other objects to be active. And so that's what this vision offset mode does. Although there are two types of it. One is raycast, that is more suitable for first person, that as if there's ray cast from your eyes. And then the round version, that is good for bird eye view or third person views, when you want to have like a certain amount of cells around the character to be visible. So, and of course there's prefab root that tells this component where it need to look for the elements of the maze, the walls, columns, and everything else. So let's start with one of our mazes. It will take a while for it to start because it needs to calculate that vision. So this is the first person view, one of the mazes that's generated. This is the maze one. And so I can press a space to dash between the cells for now, but of course it depends on the game how to deal with dashing and movement. So okay, and the interesting thing that I put here, I mean, interesting for me, is that we can teleport between mazes. So here, and as you can see, the teleportation and changing the camera angle. So this is the third person rotating, and this is without rotation of the camera, just the character. Okay, let's go, sorry. And again, dash. As you see, it's only one cell around the main character is visible, and we can change the level by like pressing key or just go on this ramp. Okay. And what else? Let's back to this one. So as you can see, there is columns, walls, and floors are the main things. The ceilings at this moment, this version of the tool is actually just a part of the floor, so it's the under of the, so it's above the current floor. So this and this are actually one object in terms of the maze generation. And let's stop for a bit. So in this, I told that this is like a root for the prefab, I mean the maze elements, and this is the root, and you see a lot of things here. And for each of them, we can define a prefab setting that we can tell what that object is. So here is the column, and we can assign a pool. This is pool on the web inside a weight. That is the weight one, and that means when the the toolkit is randomizing the elements, it will give a weight of 1 to find which column should put in a specific position. But here is we have only one column because this one doesn't have any prefab setting attached to it. But for the floors, we have like 3 floors here, and 2 of them have the pool weight of 3, and 1 of them has 1. That means the other 2 have 3 times higher chance to appear in the maze. So I think that's it, and we have the same for the walls. For the walls, of course, we can define the type of the wall. Is it open, is it see-through, or is it closed? That is important for both access through the walls and that vision calculations at the beginning. I think that was the summary of this simple toolkit that I've developed. Thank you for watching, and I hope I see you again next time.